Another type of a PN junction or a diode is a Zener diode. Now, Zener diode, this is the symbol what we use for a Zener diode. Small change. Zener diode was invented by a person called Zener. Okay, in the late 19th century. Late 19th century, you can say. And that's why we call it as Zener diode. Now, what exactly happens in a Zener diode? First thing, Zener diode is a special type of diode which works very well in the reverse bias condition. Okay, Zener diode will always work under reverse bias condition itself. Now, the Zener diode is heavily doped. Okay, heavily in the sense around 3 to 4% again. Fine, it is heavily doped. And because of the heavy doping, the depletion layer is very, very, very thin. Around less than 10 to the power of minus 6 meter. Okay, now suppose if I give 5 volt, let's say is the external battery, because reverse bias, right? So I have to give you a little more voltage, more potential has to be given for the diode. Suppose if you give 5 volt, then that depletion layer is so small, the electric field is going to be very high, around 5 into 10 to the power of 6 volt per meter, something like this. The electric field is very, very high. So we make use of this electric field in designing and how Zener diode works. We are going to look into that. What exactly happens here? See, we all know that in forward bias and reverse bias, forward bias the current goes, the voltage increases, after knee voltage it's going to become very high. And in the reverse bias condition, after breakdown voltage it's going to be very high. Like the graph what you're seeing. Correct? So in Zener diode, we work Zener diode or we make the Zener diode work under reverse bias condition. Okay. Now first, where are we going to use the Zener diode and how it should be connected? The first one is, it has to be connected in the reverse bias condition. Forward bias for a Zener diode is not going to work. It has to be reverse bias condition. Second one, it must have the potential we have, right? The barrier. Or just the potential you can say. It should be greater than the Zener potential. Greater than Zener potential in the sense what? That breakdown voltage is there, no? It should be greater than that breakdown voltage. Third one is, it is to be used, the Zener diode has to be used in a circuit where the current is less than the Zener current or the maximum value of the current. Only then we can use the Zener diode. Okay. Now that we know how to use the Zener diode, let's talk about one simple example of a Zener diode as to where we use it. Let's try to understand how Zener diode behaves like a voltage regulator. Okay. Look at this particular circuit. You have a fluctuating DC. Correct. The input is a fluctuating DC. And output we are going to get a stable DC. How? Let's try to understand. Okay. Now first thing, suppose say you have a fluctuating DC where the current is increasing. Okay, now as the current keeps on increasing, the voltage on the Zener diode, it's going to be the same. Okay, why? Because it is working under reverse bias condition, isn't it? So even if you increase the input current and input voltage, the Zener diode is already in the reverse bias condition. So whatever changes are going to happen, it is very small change. Correct? Because it is a small change, what happens? It will always be at constant, or it is always constant. That's a better way of saying. So what happens as the current rises in the circuit, the current in the resistance R also increases. Whereas voltage on the Zener remains constant. Did you all understand? This is what is going to happen. Same thing happens when the current starts to reduce. As the current starts to reduce, there is fluctuation. Correct? And current on the R is going to reduce. But the potential on the Zener is going to be constant. Alright, this is what is going to happen when you connect a Zener diode to the circuit. Look at this particular graph. This graph clearly shows that how potential remains constant in a Zener diode, or how we use Zener diode as a voltage regulator. Clear? So this is the use of a Zener diode. Quick recap is what? Zener diode heavily doped, and it should always work in reverse bias condition. Okay, and then the current should not be more than the Zener current, but voltage has to be more than the breakdown voltage. Correct? These are the 4 important points what we have, or these are the 4 points that we can take away from this particular video.